Sri Sai Ram. Welcome back to the physics class. So today we are going to start a new chapter called Force and Laws of Motion. In the previous chapter, we have discussed about the motion, the parameters that define the motion, and a bit of circular motion. In this chapter, we will discuss about the force and the laws of motion. That means the laws which govern the motion. Understood? So today in this class, we will study about the basics of the motion and kind of rewind the chapter of motion which you have already studied. So let us go and study about the motion. See, here you can see a boy just moving around. What is motion? Motion is nothing but the movement, right? Movement of an object. Provided that the ground is changing there, because of the view we kind of just put it in a photograph. So what happens here is, as the time is increasing, his position is varying. So to qualitatively define what is motion, we have to know the definition. If an object is changing its position with respect to time, then it is said to be in motion. That means, you can see, a object is starting at A, right? At time t equal to 0. T equal to 0 means it is a starting point. It started and reached point B. Take this time as some 2 seconds. All right. So with change in time, it also changes its position, right? That means the body is in motion from A to B. So he moved from A to B. That is the first thing. We defined the motion. Now after defining the motion, our next question will be what? Our next question will be, how far did he go? How long did the time take for him to travel? So let us go and explore it. These are called the parameters of motion, right? First parameter is the distance. What is distance? Distance is the scalar quantity that refers how much ground an object has covered during its motion. That means, see, the same example we can take here. This is the starting point A and the ending point B. So how much ground it has covered? Let us take another example. For it cannot be always this case that it has to travel in a straight line. A point B. Now he is going like this. Somewhere he went and he stopped at point B. So how much distance he covered? How much ground he covered? To know that, you have already studied in the previous class that take a thread. In a lower class also you have studied. Take a thread or take a rope and just align along the distance covered and measure it. Then you will get the distance, right? So this is a scalar quantity. What is a scalar quantity? Scalar quantity is a quantity which only have the magnitude, right? So it has the value, but it need not have a direction. See, sometimes it goes out, sometimes it goes down. It don't have a particular direction. Hence the distance is called a scalar quantity. And how we define the distance? It refers to the quantity how much ground the object has covered to reach the destination. This is what called the distance. Now let us go and see the second thing called displacement. Displacement is the vector quantity that refers how far out place an object is. It is object's overall change in position. What it basically tells is the same thing you can see here. Point A, point B. Now your friend came to you. You started from point A, reached at point B. Your friend came to you and asked, how far is your house? For example, this is your house, you came to the ground, point B is your ground. Your friend asked, how far is your house? So what you will tell? You will tell the minimum distance between these 2 points, right? The line joining these 2 points. how much you got displaced from point A to point B. So this will be the distance. You may go to a coffee shop, you may go to some other's house and reach ground. That will be your distance. But how far is it? That will be your displacement. How much displacement, how much change in position you got from point A to point B. Usually it is denoted as final position subtracted from initial position. So that becomes your what? Shortest distance between these 2 points. That we call as displacement, right? And displacement is a vector quantity. If you say my house is 30 meters away from here, if you just say 30 meters, what it implies? It can go 30 meters here, it can go 30 meters here. So you have the radius of 30 meters wherever you can go. But to be precise, to locate your house, to tell about address of your house, you need to specify a direction, right? So displacement gives you the direction also, so that you can easily point where the object is changing, where the object is heading while changing its position. So this is what we call as displacement. Let us go and see the next quantity. What is the next quantity? Time. So having known the distance and displacement, the obvious question is, how long does an object takes to complete an event? In our case, it is motion, right? So to go from here to here, you need some certain amount of time. As the distance and displacement is varying, you are taking some, you can't go instantaneously from A to B. You need some time to go from A to B. Some, for example, say 3 seconds, 4 seconds, some time. So that also decides your motion. Now, having known distance and displacement and also time, so now the next question is, how fast? How fast are you moving? This comes the first quantity, speed. Speed is a scalar quantity that refers to how fast an object is moving. That means how fast you are moving in this ground. You are taking a curvature, how fast you are going from A to B. That gives you the speed. You want to go fast, what happens? Your time taken will be less. So speed can be defined as distance by time, right? So this much ground you are covering in how much time? The time you know. So the ratio of these two will give you the speed, and this is a scalar quantity as well, because it only tells you how fast it is moving, right? It doesn't bother about which way you are going. You are slowing down or fasting up, that's what it is concerned about. It is not concerned about you are moving forward or you are moving backward. It is only concerned about you are moving at what rate you are moving. That's what it is concerned about. Now, the direction which we are talking about is concerned with the next. The quantity is velocity. What is velocity? Velocity is a vector quantity that refers to the rate at which an object changes its position, right? That means, see, you have point A here, you have point B here. Now, for example, you have point A, so you went to point B and came back. Again you went, you came back. So what our definition says? Our definition says it is the rate of change of its position, right? Here, if I am coming back to the original position, am I changing the position? So I am coming back to original position. I may take several distance, I may cover several ground because I am going forward and coming back. It may take several steps, but I am coming back to the original position again, right? So the rate of change of position is null here. That means in order to increase the rate of change in position, the walker who is walking should keep his should work in such a way to maximize this change in position. To maximize change in position, what I have to do? I have to go away from the original position, right, in this direction or any direction if you want. But here the direction matters, because change of position we are telling. When the change of position is coming, we need to know how you are going relative to the original position. So the rate of change of position gives you the what? Velocity, and rate of change of position is given by displacement by time, and this is a vector quantity because it has a direction without which we can't determine whether he is coming back to original position or going somewhere. So by definition we defined velocity in such a way that rate of change of position gives you velocity. Hence we defined in such a way it has to be a vector quantity. Okay. Now the last parameter we have studied, which is called acceleration. Acceleration is a quantity that refers to the rate at which an object changes its velocity. That means, see here you know that the object is changing its position at some rate, but you can see in your TV ads, Bajaj Pulsar, something in ads you can see in 6 seconds it goes up to 100 kilometers per hour. That means the velocity is starting from 0 to increasing to 100 in short span of time. The rate of increase of velocity is that. That means it is increasing its velocity, it is increased its rate of change of position. It may increase or it may decrease, but the rate of change of this quantity, velocity, sometimes it may go fast, sometimes it may go less. But the quantity we define is acceleration, is the rate of change of this quantity. That we call as acceleration. What is acceleration? Rate of change of velocity, which is given by final velocity minus initial velocity by time. What are the units of this? Meter per second by second, which gives you meter per second square, right? This is what we have discussed in the last class. Now, before going further and discussing what is there, this motion, we are talking about the movement of any object, which in turn tells you that science has started when we describe the motion. So what all we are seeing nowadays, electromagnetism, optics, everything started with the ground theory of motion. When we describe this quantity, slowly the scientific thought process has progressed, right? So this idea of motion, of moving bodies, the whole together we call as a branch that I will show, mechanics. So this branch is what we studied about motion, comes under kinematics. What is kinematics? Kinematics generally refers to a study of properties of motion, which is position, velocity, acceleration, which we have just discussed, without any consideration of why those quantities have the values they do. That means when you describe a motion, here we only describe about the speed, velocity, the parameters that are that they need during motion, right? Something is moving with some velocity, something is moving with some speed, something is taking this much time to complete the motion. So these are terms we are using, and we are seeing that how they are moving, how much time they are getting. That means we are only seeing the things without bothering about the cause of this motion. Why the body is moving with certain speed, why the body is moving with some certain velocity. In this branch of physics, in this branch of which we saw kinematics, in that branch of physics we only discuss about the motion without without consideration of why the motion has actually occurred. All right, this is the, so the other branch of physics which we call as dynamics means the study of rules governing the cause of motion, which allow you to determine why the quantities have the values they do. This is what we study in this chapter, the laws of motion. So force and laws of motion is a dynamics, is a dynamics part of the mechanics. So mechanics, you saw it is divided into kinematics and dynamics. So in the first chapter, motion, we studied about the kinematics part of thing. Now we want to study what are the rules that govern the motion. Yes, everything is moving. This object is moving with this much speed, this object is moving with this much velocity, but we need to know why this object is acquiring this velocity. What is the reason behind it? So this gives you the chapter, the force and laws of motion. All right. So let us go and study what the force is. Force is a push or a pull of an object that causes the object to speed up, slow down, or stay at one place. All right. That means you have an object, it is at rest, something, it is doing something. You are making something to it, you are pushing or pulling something to it, you are making something to it that causes change in its speed, change in its velocity, or it stays at the same in the same space. That is a special case, we will discuss about it. So generally our favorite definition is force is a push or a pull. If you push something, it moves. If you pull something, also it moves. That means you are changing its velocity. You are either speeding up or slowing down or making it to stay at one place. All right. So in this force, we discussed there are two kinds of force. Just now I told you, if an object is staying in the same space, we tend to believe that no force is acting on it. All right. So now we will see how many kinds of forces are there. There are two types of forces. A force where two or more forces of equal size act on body in opposing directions is known as a balanced force. In balanced force, a body continued to be in its position. See the diagram. You can see, you all will be familiar with this game called tug of war, where two teams will be pulling each other, and so the team which wins will pulling the other team in that direction. So what the diagram depicts here is, in the diagram you can see two people of equal strength, they are pulling each other. So that rope is moving nowhere. So that means the force which they are pulling, the one team is pulling with one force, one strength of force, other team is pulling with other strength of force. But when the strength of force is equal, that means there is no movement. For example, here again, you have a body here. This is a stone. All right. So some amount of force, 5 Newton, you are applying on it. The same amount of force if you apply on opposite direction, then the body will not move, because the force on the either sides are balanced. Do you understand? If you have another force of here 5 Newton. So naturally you may think that the object should go down, right? If I add another more 5 Newton here, will the object move? The object will not move. When the object is not moving, what is our basic intuition tells? There is no force on it. No, there is a force on it. But every force is cancelling out each other in opposite directions. That is the reason the body is not moving. Or if a body is moving in space, okay, this is space, body is moving with some velocity v, okay, this is the vector direction, okay, it is in, this is the body, it is moving in space with some velocity. What we define as a force? If a force is acting on a body, that means it should speed up or slow down or make it such that it should be at rest, right? Now this object is moving with uniform velocity. After you see, after 10 seconds it moves, for example, 5 meter per second. Here it came. Here also you saw it is 5 meter per second. Is the velocity increasing? No, the velocity is not increasing. Can we say if the body is moving, the force is acting on the body? No, because if the force has to act on a body, it should either increase the velocity or decrease the velocity. Rest is the special case where the velocity is equal to 0, right? So now here as the velocity is not increasing, we cannot say that it is under the influence of force. It is under the influence of balanced force. Understood? If it is if every force on it is acting to nullify, then the object has nothing to do with it. It will continue to progress in its own motion. It was started with 5 meter per second and it will continue to be in 5 meter per second. All the other forces acting on it is nullified, cancelling each other out. So this body will not bother about those forces, but the forces are acting on this body which are balanced. Understood? Now this is the first kind of force. It is easy to guess what is the second kind of force, and the second kind of force is which is called as unbalanced force. What is unbalanced force? A force where 2 or more forces acting in opposing directions on a body are not equal in magnitude is known as unbalanced force. In an unbalanced force, a body is changing its position, a body changes its position, which means here also the body is changing its position, but the velocity is being the same. Now for unbalanced force, what is the criteria is it should increase or decrease the velocity. If you see this moving body, at this time if you saw it became 3 meter per second, that means you can think of some kind of unbalanced force is on this body, which is why it is slowing down. To take you to the previous example which we have showed earlier, the tug of war thing, right? Let's go to that example. In previously you can see there is no movement. Now you can see there is 4 men on the right side and 3 men on the left side, which means the strength of force on the right side is more than the strength of force on the left side. It is basic intuition, right? Those 4 will easily pull out those 3. This is unbalanced. Previously you have 2 men on the left side, 2 men on the right side of equal potential. Now you can see 4 men on the right and 3 men on the right, which is unbalancing the strength. That is the unbalancing the force. So which is what the thread is coming towards the 4 men who are pulling it. So, hence they will win, right? This is about the balanced and unbalanced kinds of forces. So in this chapter, what we have in this session, what we have learnt is First we start with the basics of what is motion, and we slowly dig it down. What are speed, velocity, distance, displacement, time, acceleration, these parameters we kind of recapped again. And then we dived into force, and we studied about the branches of mechanics, which is called kinematics and dynamics. Kinematics deals with only the motion, but dynamics deals with the cause of the motion. And then we kind of, with the basic definition, we studied about force, which we call as push or pull on an object which changes its velocity. And then we studied about the kinds of forces, which is balanced and unbalanced. Hope you enjoyed this session. In the next session, it will be even more interesting, which we study about the first law of motion. Till then, thank you. Sai Ram.